Tomorrow we will look at the stretching and shrinking of our graphs. So, first we need to be able to identify what makes a graph move a certain way. And so I think I left you a little blank spot there. If you take a function and you add something onto the end, for example, if I said like x squared plus 4, what happens if you add something onto the end? Do you know how it will shift our graph? Use your graphing calculator real quick. I want you to plug in x squared plus 4. So go to your y equals x squared plus 4. How does that look in comparison to the regular x squared, the regular parabola? What happened to it? It went up. So if you add onto the end, it will move up, however much you're adding. So if I added c, it goes up c. In this case, it moved up 4. What do you think would happen if I subtracted on the end? So if I did like x squared minus 3, what would that do to my graph? Down. Okay, so anything on the outside of our function. So it's not in parentheses with the square, it's tacked on the end. Anything on the end changes y and it does what it says. Adding goes up, subtracting goes down. If it is on the inside, so if I said I want to add something on the inside, for instance, if I said x plus 2 with a square on the outside, look on your calculators, plug in parentheses x plus 2, and then put a square on the outside. How does that move your graph from the normal parabola? It went left. What would happen if I subtracted? Move right. Okay, inside. So if it's in the parentheses, it's changing our x, and it actually goes the opposite of what you think. So when you add, it moves it in the negative direction. It takes it to the left. When you subtract, it moves it in the positive direction. It goes to the right. So outside, y does what it says. Inside, x does the opposite. All right, so these are the rules that we're using today. We are going to be graphing today. So that's why I did print for you, so you have your grid. And we are going to, when we graph these, always do a parent function and the transformation. So in this case, my parent function is x cubed. Do you guys remember what x cubed looks like? Yeah. When in doubt, what could you do if you didn't remember? But on the test, you don't have that calculator. Make a table. Can we just do a table verbally? If I put in 0, 0 to the third is? If I put in 1, 1 to the third? 2 to the third? Negative 1 to the third? And negative 2 to the third? Okay, this was on that handout from last week when we did our parent functions. What I want you to do is when we're graphing that parent function, the original, we will always do it as a dashed line. That's what tells me it was the original. Okay, if you don't want to do a dashed line, then you have to label which is which. Then I want to do this transformation. What would a plus 4 on the end do to my graph? So I'm going to take each point that I just plotted and move them up 4. So outside is y, does what it says. I'm just taking each point, sliding them up 4. In general, my rule, you have to have a minimum of 3 exact points on both the parent function and your final graph. Okay, so more is better. If you don't know what it looks like, definitely do more. If I know that this looks like the chair and I just want to put 3 points on it, that's fine. But I'm checking, do you have at least 3 exact points, and is your graph in the right spot?
You should allow us to use the calculator on the test.
Hmm.
You're supposed to study how you're gonna take the test. Just like you're supposed to practice how you play.
Oh, well. Just a thought. I'll take that into consideration.
Just a friendly thought.
Appreciate the input there. All right. Whoops. What if I gave you this one? What is my parent function? Square root. So the square root of 0 is the square root of 1. What's another one I can put in? Square root of 4 is 2. If you wanted square root of 9 is 3. Can you put in negatives? You get an imaginary underneath. You try to do the square root of a negative. So this is the graph that can't extend in the negative direction. It was just half of 1. It looked like this. What will a minus 3 outside that do? Outside is y, does what it says. So I take each of those points that I just plotted and move them down 3. Shape of my graph doesn't change. And so it looks like that. Any questions there? What if I asked you to give me the equation of this? What is my parent function on both of these? X squared is more curved. What makes it have a corner? It has something else with it. Look at absolute value. So the absolute value graph, 0, 0, 1, 1, 2, 2, the absolute value of -1 is 1, -2 is 2. Remember, it looked like this. What happened to my absolute value graph? It was moved down 2. So my equation, if we want to go down 2, we just have to have a -2 on the end. B, this one's still an absolute value. How was this one moved? Up 1. So what would we put on the end? +1. Any questions on that one? Let's look at this one. G of x is x cubed. That's my parent function. So we know we've already done that one once. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, -1, -1, -2, -8. So if I asked you to find g of x minus 3, what would that minus 3 do to my graph? Inside x does the opposite. So subtracting moves it in the positive direction. So I take each of those points and move them to the right 3. what would g of x plus 2 do? So it takes that original dash 1 left 2. I'm just doing them all in the same grid here. Mine are color coded. If you had this on an assignment, you could label which is which. So far, so good. We're going to do a couple more together, and then I'll have you guys try a couple. First one, x squared plus 1. I always want the parent function. What's my parent function here? X squared. You need at least 3 exact points. 0 squared is 0. 1 squared is 1. If you wanted, 2 squared is 4. Negative 1 squared is 1. Negative 2 squared is 4. We know that's our parabola. What will the plus 1 do to my graph? It's on the outside. Outside is y. Does what it says. So I take each point and move it up 1. On B, what's my parent function? Yeah, it's the cube root of x. My transformation is going to move right 4. So we have to start with our cube root. If you don't remember what it looks like, plug in points. Cube root of 0 is 0. Cube root of 1 is 1. What's another number we can do the cube root of? 8. Cube root of 8 is 2. Cube root of negative 1 is negative 1. Negative 8 is negative 2. Like our sideways chair. And then I take all points. It's on the inside, so right. Inside because it's either in parentheses or under the radical. I want you guys to do C and D. Parent function and transformation, minimum of 3 exact points on each. So first one, our parent function is the square root of x. So 0, 0, 1, 1, 4, 2, if you wanted, 9, 3. Remember, square root can't extend in the negative. What's my transformation this time? What's happening? Inside is x, does the opposite. So adding moves it in the negative direction. All right, last one, x cubed. We've done that one several times today. That's our chair. 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. And what does the minus 4 do? It's on the outside. It's not being cubed. It's not in the parentheses. So it will go, if it were in parentheses with the cube on the inside, then it would go right, since it's just tacked on the end. We're going down 4. So it should look like that. All right, questions on those? Couple more. If I want the equation, what's my parent function on both of these? So I know it's an absolute value. How did this one move my absolute value? Right. It went right 4. So inside is x, it does the opposite. So it has to be x minus 4 inside my absolute value. B, How was this one move?
Left two.
No, it left 2, so it had to be in my absolute values.
X plus two.
All the ones we've looked at so far only had one transformation, but we can have more than one. So let's try a couple that have 2 different options, or 2 different transformations. What's my parent function here?
Absolute value.
That's the value of 0, 0, 1, 1, 2, 2, and 1, 1, negative 2, 2. It's just my v. How is this graph being moved?
Plus two is out.
So, I go take each point left and down. On B, what's my parent function? X cubed, so that's our share, 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. Okay, what's the transformation here? Inside moves X, opposite what we think, outside is Y, does what it says. So each point right and up. Are there any questions there? Then the last thing I want to do is make sure you guys can give me domains and ranges. So, if I gave you this, did I say you had to do a parent function and transformation? No. If you can look at it and you know the domain and range, excellent. By all means, go for it. But if I don't know, what should I do? Draw a graph, okay? I know x squared, my graph is almost too small, is my parabola. What's going to happen on this one? How's it going to get moved? So your parent function, I'm just drawing a really rough sketch here. I know it will go right and up. I go right 1 and up 2. What's the domain of every parabola? Range. If I'm looking at this one, moving it up 2 moved my range. So it's now at. So could you have got that from the equation? Sure. If you know parabolas go forever in both directions, domain is everything. Parabola normally starts at 0, it went up 2. The graph isn't required, but it helps to have that visual. On B, do you know what your domain and range would be? What's the x cubed look like? So if I graphed my chair, how is this graph getting moved? So if I go What's my domain? Yep, chair keeps going both directions. My range, one end's going up, one end's going down. So, if you remembered what the chair looked like, could you have identified that before? Yes. If you don't, does it take that long to sketch the graph? No. Alright. C. What's my square root graph look like? Right. Square root of 0, 0, 1, 1, 4, 2. How is this one moving? I go right and down. What's my domain on that? Now, because I moved right to, it starts at 2. What's my range? So if all I'm asking is domain and range, draw a graph if it helps you, but it isn't required. Alright, what questions do you guys have? Okay. There's